Okay, let's go through our angles here. This is the first time we've seen angles, and we're going to talk about how to name them and how to write them. So first of all, our first term is something we've seen before. It is a ray. A ray is a part of a line that has one endpoint and extends forever in one direction. How to name it, we've also talked about this. We have to make sure our arrow goes to the right every time. And then I'm going to put my endpoint at the start, and then the arrow is closer to P, so I put P on the right side. Next, we have blank share an endpoint. I'm just highlighting over here. It says blank shares an endpoint and form a line. Basically what we have here, what I've highlighted, is two rays. One's pointing to the left and one's pointing to the right. We call them opposite rays. They're going in opposite directions. If I write them, I've got to put both arrows going to the right though. Well, both of their endpoints are J, so those are both going to be at the start, and then one of them was going to the right with K being closer to the arrow. The other one had H being closer to the arrow. That's how I would write both of those. Next, an angle is formed by two non-collinear rays that have a common endpoint. The rays are called the sides, and the common endpoint is the vertex. So if I come over here, this is a side, this is a side, and this is a vertex. Okay? The vertex is just this point. That's what I'm talking about there with the vertex. The sides are rays. If I'm if I'm writing an angle, there's three ways I can do it. First of all, I could just call it angle 3, because this 3 right there is denoting that angle. I could also call it angle YXZ. And the way that I describe this is like a connect the dots. If I go from Y to X to Z, that's that angle right there. I could also label it angle ZXY, because that still works with connect the dots, ZXY. Now I'm just going to quickly say what you can't do, and that is you cannot say it is XZY, because even though all of those points are on the angle, if I connect the dots here, so X to Z to Y, is that really the same angle? No, it's not. So, do not do that. All right, moving on. We're talking about interior and exteriors of angles. That's what these two are, interior and exterior. And basically what it's trying to get at here is by saying this is the interior of the angle, like the smaller portion of it, right? And then this would be the exterior of the angle, which is on the, like the outside, you could call that, right? Okay, moving on. Now what we have here is like a map of a, I think it's like a school or something like that. It says name all the angles that have B as a vertex. Well, again, if I'm doing like the connect the dots, B would be my middle part, so A to B to D would be one. So angle A, B, D would be one of them. I would also say D, B, C would be one. D, B, C. Now I could call that angle 2. Oops, sorry about that. I could call that angle 2 if I wanted to. And I could have also called the first one angle 1. But I'm just going to use letters for this right now. Okay, it says next we're going to label or name the sides of angle 3. Angle 3 looks like it's this one right here. And one of the sides would be, well, we've already said the sides of an angle are rays, so I'm just going to keep them as rays. So one of them would be this street right there. The other one would be this one right here. And we're going to assume that there's arrows on those. So I'm going to say C is my endpoint and B is closer to my arrow if it was going this way. And then on the other one, CE would be another side. With the sides, they're always going to be rays, which means they're always going to be just 2 letters. I've had so many kids try to type in 3 letters on the homework for a side. You got to realize that's an angle. If you're doing 3 letters, you're talking about an angle. 2 letters would be a side. Okay? What's another name for GHL? Okay, so let's see. GHL. Connect the dots. Okay? G to H to L. If I'm calling it by another name, I'm just going to use that 7 right there. I'm going to call it angle 7. You could also call it angle LHG if you wanted to. There's actually, there's 2 of them. I'll write it down anyway. So LHG would be your other one. Name a point on the interior of DBK. So from D to B, oh, K is down there. So this is like, I'm going to redo that, sorry. So D to B to K. That's my angle. I see point E there on the inside. All right, we're classifying angles now. You've seen this before, so I'm going to make it quick. This is an acute angle. This one is a right angle. This one is obtuse. And this one is straight. Oops. Straight angles are the ones that you might not have seen before. That's just a 180-degree angle. Classify each angle from the figure at the right. M to J to P. Again, this is like connect the dots. MJP. That would be M to J to P. That is a 90-degree angle, and we can tell because there's that little 90-degree box there. So let's put 90 degrees or right angle. Next one, L to J to P. L to J to P. It looks bigger than that 90-degree angle, so I'm going to put that as obtuse. N to J to P is definitely an acute angle. And then K to J to P, that is definitely a straight angle. Okay. Just as segments that have the same measure are congruent segments, the angles that have the same measure are congruent angles. So it's important here to note, when we are talking about congruent and equal in terms of like segments, we write them a little different. If we're writing segments, it's like A, B, and C, D with lines over the top or segments over the top. We call those congruent. If you are doing an equal sign though, AB is equal to CD, we don't have those segments over the top. Remember, I've kind of discussed with my class, it's like 2 separate languages. One of them is written this way and one of them is written the other way. They mean essentially the same thing. Just like with different languages, you can mean the same thing, but they just look different. So the same thing applies when we're talking about angles. When we have an equal sign, it looks like this. We have to put an M in front of our angles. That M stands for the word measure. Okay, so in the figure, it says the measure of ABC equals the measure of FED. And then it's also showing you, if it's a congruent symbol, we no longer put measure in front. That's just saying then that angle is congruent to the other angle. Matching the number of arcs in a figure also indicates congruent angles. We've talked about this in class too. If we have 2 segments, and I know those don't look very similar, but they're okay now. If I put tick marks on them, then you know those are congruent. When we're talking about angles though, we actually use arcs. So this one has 2 arcs on it, and so does this one. So those are congruent angles. This one only has 1 arc, and this one only has 1 arc, so those are congruent angles. If I can zoom in, you can kind of see it even a little bit better, right? So, let's go down here, the angle addition postulate. Basically what this is saying is, if you have this angle, right here, actually I'll just color in the whole thing. If you have this angle, and you add it to this red angle, so the orange angle plus the red angle, if you add them together, it will equal the entire thing. All of this. It will equal everything. So a small angle plus a small angle basically equals a big angle. That's what they're trying to get at there. So if I'm writing that out, I'm going to go with my connect the dots, A, B to D. So angle A, B, D. Oops, and I forgot already. I'm going to have to put measuring there, a measure of angle ABD, because I'm going to actually be using an equal symbol on this one. Measure of ABD plus the measure of the smaller angle, DBC, equals, we said the whole thing, which was the measure of A to B to C. And that is our angle addition postulate. All right, so this question that's coming up here is one that we will see on your Alex homework. It says, in the figure below, the measure of angle 1 is 36. And the measure of TSW, which is the whole thing, T to S to W, is 73. So I'm just going to do this to show the whole thing is 73. It wants us to find the measure of angle 2. Well, if the whole thing is 73 and that measure of angle 1 is 36, I just have to subtract them. So 73 minus 36, that means this one has to be 37. So the measure of angle 2 equals 37. That's pretty simple, but they do get a little bit more tricky. On the next one, it says, in the figure below, ABD, which is that whole thing, right? ABD is 92 degrees. Then it says measure of angle 2 is 16 more than the measure of angle 1. Well, it's 16 degrees more, but I don't know what measure of angle 1 is, so it's going to be kind of tough to find it. Okay, so here's what we got to do. I don't know what the number is, what the measure of angle 1 is, and in math, when we don't know what a number is, we make it a variable. So the measure of angle 1, I'm just going to say that's x. I know the measure of angle 2 is 16 more than the measure of angle 1, so I can just say the measure of angle 2 here is x plus 16. So whatever we find out x is, that's what this is, and then we're going to add 16 to it. Now what I'm going to do is I'm basically going to use my angle addition postulate, and I'm going to say, well, that's angle 1, or x. We said that was the same, right? We just defined it as x, plus angle 2, which is x plus 16, equals 92. Again, let me highlight this and maybe it'll make more sense. I'm taking this one, which is the same as this, adding it to this, which is this, and that's going to equal the whole thing. Oops, I got to do a different color. The whole thing, which is that. Now, as we go through, this is just algebra. So we'll have 2x plus 16 equals 92, minus 16 from both sides. 2x equals 76. Divide by 2, divide by 2. X is going to equal 38. And we are done. That's what it wanted. It said find the measure of angle 1, but that is what x is. So I guess we could say measure of angle 1 equals 38 if we wanted to. Okay, this one is very similar, so I'm going to do it a little bit quicker here. It says find the measure of angle 1. It says the whole thing is 105. And the measure of angle 2 is 4 times the measure of angle 1. So I don't know the measure of angle 1, but I know the measure of angle 2 is 4 times the measure of angle 1. So if I add those together, it'll be x plus 4x equals 105. If I add those together, I'll get 5x equals 105. So x, which is the same thing as the measure of angle 1, is going to equal 21 degrees. And that is my final answer.